Okay, so now we're going to take a look at limits, but looking at it with an algebraic approach, looking at it analytically, what's happening as we plug in numbers of x, or close to that x value we're looking at the limit of. So again, this is the intuitive definition of a limit. So it's not really the former definition of a limit, but don't worry about it. We won't get into that in this class. You need to just understand the intuitive definition. So the limit as x is approaching a of f of x is equal to L. So we're approaching some x value. What is that y value we're approaching? It's computed by making f of x values arbitrarily close to L, but not equal to L, but by restricting your x values to be sufficient to be close to x equals a. F of x is defined when x is a number near that number a. So I kind of gave you a picture before, and let's just kind of look at that again. So what could be happening here for this definition is, in this case, they use a variable a. Last time we used c. So let's say that we have some value of a here. This is saying that we're going to be approaching some y value L. If we can choose something close to L, so some value that's coming in here close to this y value L, there's a value arbitrarily close to A. So like right here. I hit the graph here, this is my A value. So I'm getting inside close to A. If I hit the y value here, if I look at my graph, that's hitting a value close to A. So as I'm getting closer and closer to A, is my y value getting closer and closer to L. Okay, so again, that's the graphical approach of what's happening. So now let's look at this algebraically. So let's look at one example, and we want to find the limit as x is approaching 1 of f of x, which is the function x minus 1 all over x squared minus 1. And we want to see what's happening when x is equal to 1. If you notice there, that function f of x equals, just define it, x squared minus 1 all over x, oh, sorry, that was x minus 1 all over x squared minus 1. So if we plug in f of 1, if we're looking at this to see what is the x value, or sorry, what is the y value when x is 1? So to do that, you're just going to go back to your function. Wherever you see an x, you're going to plug in 1. So what I tend to do when I'm looking at a function and I'm evaluating it at a number, I'll go in and I'll plug in a parentheses, put parentheses wherever you see an x. So in this function, I see an x, I'm going to put parentheses minus 1. In the denominator, I see an x squared, so I'm going to put a parentheses and then I'm going to put a square there, minus 1. And now wherever you see that parentheses, we're going to go back in here and we're evaluating. We're going to replace that x value with 1. If we do that, notice the numerator using order of operations. In the numerator, we have 1 minus 1, which is 0, all over the denominator, which is 1 squared, which is 1, and 1 minus 1 is 0. So when we get things in this form where we get 0 over 0, or later we'll see it infinity over infinity, this isn't telling us anything about the graph and what's happening there at x equals 1. This is actually called an indeterminate form. Indeterminate. Form. And so if we get something in this form, we have to go back and we have to try to solve this differently. So we'll look at tools soon on how we can manipulate these different rational functions to get it out of the form of 0 over 0. Or we can do what we're going to do right now by looking at values getting really, really close to that limit as x is approaching 1, but not exactly at 1. So here, let's look at that. So let's choose some number that is to the left of 1, but close. So choosing a number where x is less than 1. So maybe let's try, first of all, 0.5. And so we would want to go in here to our function f of x, and wherever we see an x, this time we're going to plug in 0.5, and we're going to simplify. So let's go back into that function. Wherever you see an x, put a parentheses, and then replace inside that parentheses with a 0.5. Use your order of operations, that PEMDAS. This is where PEMDAS is really helpful. That was one of your comments in your meet and greet, I think. So we have a 0.5 minus 1. So we treat the numerator as a bracket or parentheses, work inside that. 0.5 minus 1, that reduces to negative 0.5. All over 0.5 quantity squared, parentheses and exponents. So let's ignore the decimal for a second. 5 times 5 is 25, but where that decimal is tells me I got to move it over twice. So this is the same thing as 0.25 minus 1. So this is equal to negative 0.5 all over negative 0.75. Technically, I still could do this without a calculator. I could clear my fractions or decimals within the fractions, right? Multiply by a fancy one, 10 over 10. They're both negative, I get a positive. So this one moves my decimal place over. Actually, let's multiply by 100. So 2 zeros move this over twice. So this is 50 all over 75. Both are divisible by 25, which gives us 2/3. Okay, so 2/3 though, if we look at that, we get 0.6 and then with a bar over it. So this is really 0.666666666, that going on infinitely. And you'd find that if you did 2 divided by 3 in your calculator. Okay, so that's a number kind of close to 1 on the left, but now we want to see even something closer. So then you put in, let's say 0.9, and then someone maybe put in 0.99, and maybe someone else put in 0.999. So those are numbers that are even getting closer and closer to x equals 1 on the left. So this could get kind of tedious. Can you see if when we're starting to put in numbers, if there was a lot of values of x in there, putting it in and then having to simplify. This is where I would let you use a calculator. But let me show you. Sorry, I saw the the message on the chat, so I just want to make sure I wasn't missing anything. So Desmos, this will be your friend, and you guys can use this for certain pieces of your homework where you're going to have to plug in values like that into some function. And so Desmos.com is a cool feature. Unless you have a graphing calculator, you can use that too, but you can't use that on a test. So go to Math Tools in Desmos.com, go to Scientific Calculator. We're going to define our function. So f of x, this was the rational function equal to, what was it, x minus 1. I'm going to put parentheses around that whole thing so that it knows that this is a rational function. And then I'm going to push divide, and then the next piece of that rational function was x squared minus 1. So x, you can do the caret symbol and it will bring you up to that power, or you can use the keyboard. Squared minus 1. So if I push enter now, and I go in and let's evaluate it first. We looked at f of 0.5. And so if I look at f of 0.5, notice here it's giving me what my y value is, 0.66666, and it rounded it there to 7. I could look at it as a fraction, which we found was 2/3. For us to figure out, though, what value the y value is approaching, it's easier to look at it in decimal form. And so now let's go in, push enter, and let's look at what was that f of 0.9. And so if we get that, I notice I get 0.5263. Okay, so maybe it's approaching some number, but I'm not sure yet. So you want to keep doing this until you get something that looks like it's coming to the same value, or that it's just blowing up or not going to any one y value. So right now it may look like it's getting closer and closer to a half, right? So if I did f point and then go out even further, notice that the more I put in 9s after that decimal, it's looking like I'm getting closer to a half. So I could pretty much see that this is going to 1/2 on the left-hand side. But that's only the one side of the limit. So we also want to do the same thing. We want to look on the right-hand side. So let me just go back here for a second and let's plug that in. So we had like 0.5. So one of these was like 0.52. And we saw that this was going to 0.5. So I could see as a limit, I could write this in limit notation as x was approaching 1 on the left-hand side, that superscript with a negative sign of f of x equals 1/2. So I want to do the same exact thing. I want to go back in, but now I want to choose values of x. When I plug it in, I want to choose values of x that are to the right of 1, so bigger than 1. So I already have that function defined in Desmos. So I can just now go in and let's look at how about f of 1.5. So I get 0.4 there. 1.5. We got 1.4. I'm sorry, we just got 0.4, right? And then let's look at how about 1.1. So that's even closer to 1 on the right-hand side. So if we now plug in 1.1, so f of 1.1, I'm looking like I'm getting to, so here's 0.476. 0.476. So it's looking like it's getting up to that 1/2, but let's just try, make sure. So 1 point, how about 0.1? So that's even getting closer. And that y value is 0.4975. Let's just add a little more zeros for that 1 and after the decimal. Okay, and so again, notice that this is getting closer and closer to 1/2 on the right-hand side. So if I go back in here, so as we did 1.01, 1.0001, we saw that the limit as x is approaching 1 on the right of f of x is equal 1/2. And because the left-hand side and the right-hand side are approaching the same number, we can say that limit exists. So the limit as x approaches 1 of this function, x minus 1 all over x squared minus 1 is equal to 1/2. Okay, so recall I said that when we had plugged in 1 into this function, we got back the indeterminate form. We got a 0 in our denominator. So recall that we have values to be in your domain. Values that are in your domain are your x values that if you plug back into a function, you get back a real number. And if you get 0 in the denominator, it doesn't exist. So notice also, if you looked at this rational function, x minus 1 all over x squared minus 1, if we had factored the denominator, I'm just going to write it up here. So x minus 1, notice that there's 2 terms there. And so when you are going about factoring, a lot of times it's helpful to first identify how many terms you have that you're trying to factor, which we have 2. If you have 2, then you want to see if that's a difference of squares or a difference or sum of cubes. And this I can see is a difference of squares. There's something I can square to get the first term, and there's something I can square to get the last term. And so recall, so this is kind of one of those review really quickly. If you have something in the form of a squared minus b squared, this can factor difference of squares as a minus b, a plus b. And so that denominator, x squared minus 1, is x minus 1, x plus 1. And so notice I have common factors in the numerator and denominator. So that grouping of x minus 1 in the numerator can cancel with that grouping of x minus 1 in the denominator. And so if we do that, we get back, well, we only have a 1 left in the numerator because that's like 1 times that expression, x minus 1. And then in the denominator, we have x plus 1. Okay, so it's important to know that x is not, again, x equals 1 is not in our domain of f of x. But now let's look at this and plug it into the simplified form of f of x. If we go back in and we use f of x as 1 over x plus 1, and we just look at what's happening at f of 1 here. So we go in and we plug in a 1 wherever we see an x. So we have 1 all over, see an x there, put parentheses, plus 1. And so notice when we plug in 1 there for x in this case, the simplified form, that we get 1 over, and then the numerator we get 1 plus 1, which is 2, which is 1/2. This is the same limit that we got when we looked at what was happening on the left and the right of this function. So I just want you again to look at, just take a moment because we have decimals up, you can see what this graph looks like. And then we can look at that graph and see what's going on with the y value as we get closer and closer to 1. Is that y value 1/2? So this is another way to check it. So same program, desmos.com. Go. So math tools up here, graphing calculator. So we can go and look at this graph. And I need to define it. And so I can either define it as y equals f of x equals, or in this case, you can actually just put in the expression. But let's just do y equals. So y equals, I need parentheses, x minus 1. So it knows that now when I do the division, that whole x minus 1 is in the numerator. All over x, I'm going to put the caret. So that tells it to go up into the exponent. You can push the arrow to the right to get out of the exponent, minus 1. Let me zoom in here because we were looking at the limit as x is approaching 1. So as I zoom in here to x is approaching 1 on the graph, This actually doesn't show the open circle that should be here, and that just has to do with the graphing program and how programs are working when they're graphing. It's plugging in numbers very, very close. It has to do with this limit. It's plugging in numbers really, really close to 1, and it's determining that this value actually exists, which it doesn't. So that is a flaw with these things. But you can see, though, the y value as x is approaching 1 is getting closer and closer to 1/2. So that is, in a nutshell, what's going on algebraically. We're plugging in numbers, getting closer and closer to that x value on the left and the right to see, are we going to the same y value? And if so, even if that value doesn't exist in our function, if we're going to the same y value on the left and the right, the limit exists.